As John said, I work for Aconex, and Melb.js is there, so definitely come along and check it out. So I'm talking about data structures in ECMA 6 script, version 6 JavaScript, whatever you want to call it, and they really fall into these four of the 7 themes that they're talking about. So let's recap our existing data structures we have. If we think about the object as a data structure, what is it? It's an associative array that maps strings to anything. And it also has the prototypical inheritance that we know and love. So let's have a look at an object. We can construct an object in 2 ways. We can set a value, so we can got the key, a string key value, and then a value on the other side. The value can be a DOM node, it can be something else. And if we want to get a value back, we use that notation, very easy. But there's a few surprises. You can get values back that you weren't necessarily expecting because of the prototypical inheritance. Similarly, if we try to iterate over an object, we might do something like this, but then the key values that you get back are also going to be from the prototype chain, potentially. So to protect yourself from that, you might write some code that looks like this. And that'll work, but it's not really something you want to be doing every day. So what is the object? Is it a data structure? Is it for inheritance? Why not both? It's not actually that great. But don't worry, we're going to fix that with ES6. So arrays are getting a bit of love in ES6. They're the same arrays that you know and love. They map a number value to anything, and then they have the length property, which kind of gives it all of its magical superpowers. So let's have a look at the array. You construct an array like that. You can also construct an array using the from operator. The nice thing about the from operator is it'll take anything that looks like an array and then turn it into a real array. So if you've got a list of DOM nodes, you can turn that into an array very quickly using that. Similarly with arguments, you can do that. And there's also the spread operator, which is used with arrays. The spread operator basically does the same thing. It can be used in a few more ways than this, but in this case where it basically takes the thing that looks like an array, either is an array or looks like an array. And when I say looks like an array, I mean numerical indexes, and it has a length property. So as long as your object satisfies those 2 criteria, you can use it with the from or the spread operator. In this case, the spread operator just takes that thing that looks like an array and concats it into the middle of an existing array, wherever it appears. So there's some examples. So that's a lot nicer than sort of using the slice method and trying to remember how to do that. Arrays, you know how to use an array to assign values into an array. You do that sort of stuff, or you might mutate the array using some of those methods. You get values back out of the array. Getting values out of an array will actually look in the prototype chain, but it never actually happens in real life, so it's not really too much of a problem. You can pop values off. You can find values like that. It has a length property, and you iterate over an array like so. You would probably be fairly familiar with most of that stuff, I would hope. So, and there's some more examples that you'd be familiar with. A new data structure that we're getting in ES6 is the set. Now a set is basically a big bucket of things, and you can throw anything in the bucket. Any variable you have, you can throw in the bucket. But everything that's in the bucket is unique, so if you try and put the same thing in twice, nothing happens. And a set doesn't associate with anything, so it's not like an object where you have a key and a value, it's just values, or just keys, depending on how you look at it. Uniqueness is defined by the triple equals operator, almost. There's one exception to that, which you might be able to figure out for yourself. You create a set like this. There's no kind of syntactic sugar for generating a set. It's just you have to say new set. You add items to the set like this, and you'll notice we're not using subscript notation. You actually have to call the add method, and that's because these values don't end up in the same kind of data structure that the prototype works with. You can add key values, you can add numbers, you can add some JSON data in there, you can add DOM nodes, and you can add kind of special values like nan or null or undefined. So let's have a look at how this might play out as in a sort of some walk-through code. So we've got two objects, Anne and Bob, and they're unique objects. And we add Anne, we add Bob. We can test whether Anne's in there. We can add Anne again. This won't fail, but it won't do anything either. And then it has, you can tell how big it is using size. It's size, not length. I don't know why that's different, but it is. And then you can delete Anne from the set. And that will happen. The next data structure I want to talk about is the map. Now, a map is a true associative array in the sense that rather than mapping strings to anything, it maps anything to anything. So you can create a relationship between things that aren't strings. I mean, you can use strings, but you can map a value to a value that's not a string, like null. So you can say, the relationship in this program between null is this value too. Similarly, we can create a relationship between a DOM node and a function. And this doesn't change the DOM node at all. There's no, we're not using data properties or anything like that. We're actually creating a relationship outside without modifying the DOM node. It has a size property, and you get values back using get. You can delete, so that doesn't delete the DOM node, it deletes the reference to the DOM node in the map. And then clear will clear everything in the map. So let's have a look at this in real life. Once again, we've got our two objects. And in this sort of situation, you might be thinking, so these objects might be coming from another part of the system. They might be a model, and you don't want to change the data structure in any way. But we do want to associate the ages of these people with their objects. So we create an age map, and we set the age of Anne to 45 and the age of Bob to 27. And then we have a relationship. We have extra data associated with these objects without actually modifying the objects themselves. And we call the get method, and we find out how old Bob is. He's 27. Now, there's a very useful extension to the map, or it's a different data structure, but it's essentially another map called the weak map. It has a similar kind of association as the map, except the key value, the key thing with all these weak properties I'm going to introduce is that the references to the key values are weakly held with relation to the garbage collection that happens under the hood in JavaScript. And that means that a side effect of that is that you can't map primitives, you can only map objects to anything, so you can't, say, have a string in your weak map, it's an object that you're mapping a value to. And you don't have a size, because the actual size of a weak map inside the runtime is determined by the state of the garbage collection. And so you can't, as a user of JavaScript or a JavaScript program, can't tell what the size is because it's indeterminate, and you don't like indeterminism in your programs. So let's have a look. To kind of explain the value of weak maps, I'm going to run a scenario with a regular map and see how it plays out. So we have our users, and for each of these users we're going to generate an avatar component which returns a DOM node, and we're going to associate a handler with the DOM node. So some sort of function is associated to that DOM node. So maybe when you click on Ryan, you get a profile of him. And then you take that node and you attach it to a parent node. It's in the DOM and it shows up on the page. Sometime later, the user clicks the next button, the page disappears, and the parent is removed. But because there's a reference to your node, to both of your nodes inside the handlers set, inside the handlers map, those references can't be collected, and in fact, that handler will actually have both those DOM nodes in it. We'll stop those DOM nodes from being garbage collected. All of the associated images and scripts and everything, and all of the tree of DOM won't be collected. It'll sit there in memory, and you have a memory leak. If we have the exact same code, but we use a weak map, so we create our DOM, we attach the handlers to it, we attach it to the node, the relationship there exists. So whenever we get a message saying, hey, the user's clicked on this particular node, what should I do? You look inside the handler's weak map, and it'll say, oh, I've got a function you can run. I'll run that function. It'll work. When you say parent.remove, the node's removed from the DOM, so the user can't click on them anymore. There's no way that your program will ever find those DOM nodes again. And so the weak map, the garbage collection will run, the DOM nodes will be automatically removed from the weak map, and you have no memory leaks. So it's a very easy way of writing code that doesn't leak memory anymore. There's been entire releases of jQuery that have basically been dedicated to trying to fix memory leak issues. And you know, the structures they have in jQuery are very complicated because you need to kind of keep references to DOM nodes that are existent. If you don't use the right way of cleaning up after yourself, you end up with memory leaks. There's also a weak set, which has the same weak garbage collection semantics as set, but it, thanks Melissa, but it's a weak version of set, and it has a fairly limited set of useful use cases, so I'm not going to go into it too much. What kind of powers all these data structures, makes them awesome, are iterators. An iterator allows you to take these structures and get all the values from them. An iterator is basically an object that has a next method that returns a done property and a value property. And if you were paying attention at the end of the last talk, you might sort of pick up there's a bit of similarity in the API here. You can create iterators from array, map, and set, and there's other things as well that generate iterators. You can't iterate over a weak map or a weak set because you don't know the size of them, and what's in a weak map is not really deterministic within the runtime of JavaScript. So let's see an example of iterators. We have an array. We create an iterator on the array, and this will be familiar to you. You call the next method, and you get this object back, which has a done property and a value property. The value property is an array containing the key and the value. So in this case, 0 and A. If we call it again, we get 1 and B. If we call it again, we get 2 and C. If we call it again, we get done is true, and the value is undefined. And then we can, you know, our program knows to terminate, or our iteration knows to terminate. Now that's all, that appears to be quite verbose, but what we have to deal with this is the for of loop, and also destructuring helps with this a bit as well, which are coming. So if we have a for of loop, you can see that's quite a compact data structure, and that basically does the same thing as the code above. The of operator knows how to handle calling next and checking whether done is true or not, and then the destructuring takes that value and creates local variables out of, or assigns them to variables, excuse me, so that you can use them immediately. And if you compare that to a traditional for loop, you can see it's actually a bit more concise and a bit more compact and a bit more useful. You don't have to worry about length, you don't have to worry about plussing, and you have the value right there ready to go. You don't have to find it inside the index. Iterators, one nice thing is if you pass an iterator into the constructor for the array, map, or set, you'll actually get one of these data structures seeded with this value. And I think you can do the same thing with generators, where you pass a generator in and it will sort of pull everything out of the generator and put it into one of these data structures. You can use entries and keys and values to generate generators that have return different values, and that works for map and set. They all have the same API. Even set, which doesn't really have a key value, still has the same API, which I guess is just sort of for symmetry, API symmetry. There's a summary table of what I've kind of talked about. I'm not going to dwell on that too much. I guess one thing is that we're going to be still using JSON, and JSON will be creating objects, not maps. So the way that you create maps cleanly, you sort of get into this nice sweet data structure starting with JSON is not too clear to me yet, but I guess we'll figure something out. And the difference between length and size, I'm not sure why that's like that. So where are we? Firefox is leading the pack. Its version of iterables doesn't conform to the current version of the spec, but it's there, at least you can use it. IE 11 has some of these features enabled and ready to go. Chrome has some of them, but they're hidden away, so you can't really use them. And Node also has some of these things if you run with the Harmony flag. That's the end. Thank you.